In this lecture, we will now look into Hadoop and compare the operation to a Hadoop YARN system. In this example, client 1 sends app 1, application 1, to execute MapReduce operations in the HDFS. In this example, a job tracker is made on the NameNode. The job tracker could be located on a different node. In this example, it's located on the NameNode. Then a job tracker is formed to execute the job. The NameNode selects DataNodes. Then the DataNodes will start to send heartbeat signals to the NameNode every 3 seconds. The job tracker, which serves as the brain, the master, sets up multiple task trackers, which will be the workhorse, the slave nodes. Each task tracker assigns slots to be either a map slot or a reduce slot. Map slots are assigned map functions. These are JVMs. What is a JVM? I will soon explain that to you. The reduce slots are assigned reduce functions, reduce function JVMs. Parallel processing is operated based on simultaneous controlling multiple process IDs. In order to explain what a JVM is, let's look into Java. This is a trademark owned by Oracle. A JVM is a Java virtual machine. It is a virtual abstract computing system on a computer used to execute Java programs. It runs on a JRE, Java Runtime Environment. This is a software package that contains a JVM called a hotspot and JCL, which is a Java class library. JVM memory usage types include heaps, thread stacks, native handles, internal data structures, and others. JVM heaps are Java objects that are kept in the heap memory. They make the process much faster. When a JVM starts, the heap memory space is allocated. Heap size can be increased or decreased during the execution of the application. Heap management is allocated by the JVM using the operating system, and JVM conducts heap management of the Java application. Hadoop with YARN example. The resource manager has a scheduler and apps master inside. The resource manager prepares node managers on the multiple nodes in the cluster. The node managers send heartbeats to the resource manager to show that they're alive and also support updated connectivity information. A zookeeper can be applied to the resource manager for high availability protection. Client 1 submits app 1, application 1 to the resource manager. The scheduler selects a node with sufficient resources to set up app master 1 on the node manager. I do need to mention that this is app master 1 on the node manager, and on the resource manager it is apps master, it's plural. The apps master, which is on the resource manager, starts to monitor the app master 1 to check if failure occurs. Now, this monitoring process continues on for the entire duration of this application. The app master 1 communicates with the scheduler in the resource manager, requesting for containers to be set on the nodes. The scheduler sends keys and container information to app master 1 for the containers to be set up. Based on the keys and container information received from the scheduler, app master 1 contacts the node masters and sends keys and container information and requests for containers to be set up. Then each node manager contacted by app master 1 will set up a container to run app 1 on their node, and that's in the yellow app 1's assigned. Let's look at what would happen if another client were requesting for their application to run. Then app 2 will be submitted to the resource manager. The scheduler will select a node to set up app master 2. the app's master will start to monitor app master 2 to check if failure occurs. And this process will continue as long as the client 2 app is in process. App master 2 requests for container setup, and the scheduler sends key and container information to app master 2. App master 2 contacts the node managers and sends keys and container information to request for containers to be set up on their nodes. Each node manager contacted by app master 2 will set up a container to run app 2 on their node. App 2 will run on the new containers. For fault tolerance in YARN, if a container crashes, app master 1 will communicate with the resource manager and will set up a new container to replace the crashed container. If app master 1 crashes, the app's master in the resource manager will set up a new app master 1 on the same node or a different node. These are the references that I used, and I recommend them to you. Thank you.